Hello, how to solve t to the power of t to the power of 3 equals 36, solving for the value of t that satisfies this equation. So I can raise each part of this equation to the power of 3 because there is 3 here already. T to the power of t to the power of 3 raised to the power of 3, and this equals 36 raised to the power of 3. Now we consider this identity. If you have a to the power of m raised to the power of m equals a to the power of m raised to the power of n, meaning that this t power 3 here will represent my m, while the 3 will represent my m. So I need to switch it. I need to switch the powers based on this identity. The m will come inside the bracket while the n will go outside the bracket. So we are going to maintain the base, which is t, and the m will come inside the bracket, that is to the power of 3. And this is raised to the power of t power 3. And this equals 36 to the power of 3. Now from here, remember 36 is a perfect square. That means 36 equals 6 to the power of 2. So what we have here is the same as what we have here. So we need to also express this 36 in terms of 6 power 2. So I have t power 3 raised to the power of t power 3. And this equals 36 is 6 to the power of 2. And this is raised to the power of 3. Now, if you have a power n raised to the power of m equals a power n times m. 2 times 3 will give you 6, so you have t power 3 raised to the power of t power 3 equals 6 to the power of 2 times 3, that is 6. Now, if you have x power x and this equals y power y, that means x equals y. Then we need to compare this exponent. So we have t to the power of 3 equals 6. From here, we can isolate t and solve for t. I need to eliminate this 3 here. I have t to the power of 3 raised to the power of 1 over 3. And this equals 6 raised to the power of 1 over 3. And if you consider this identity again, a power n raised to the power of m equals a power n times m. You multiply this out, you are going to get t to the power of 3 times 1, that is 3 over 3, and this equals 6 power 1 over 3. And 3 divided by 3 is 1, so you have t equals 6 power 1 over 3. Now, consider this identity if you have a power 1 over n. This equals the n root of a power 1, which is the same thing as the n root of a. So this will give you the cube root of 6 power 1, which is equivalent to writing the cube root of 6. So this is our t, a final answer. That means t equals cube root of 6 or 6 power 1 over 3. Now, what we will do will be to check by inserting this value of t back into this equation. And let's see if it's going to satisfy the equation. So we have t equals the cube root of 6 or 6 power 1 over 3. Now, you have t power 3 equals 36. and t is 6 power 1 over 3. So we have 6 power 1 over 3 power 6 power 1 over 3. And this is raised to the power of 3. And this equals 36. Now, recall if you have a power n raised to the power of n equals a power n times n. I start by multiplying this exponent. So 3 times 1 over 3 will give us 3 over 3. And 3 over 3 is 1. So what we are going to have is 6 to the power of 1 over 3. And this is raised to the power of 6. Because 3 times 1 over 3 is 3 over 3, that is 1. So because of that, I can put the bracket here. And this equals 36. After eliminating this exponent, I can put the bracket here so that I can make use of this same identity again. A power n equals a power n times n. So from here, I have 6 power 1 over 3 times 6, that is 6 over 3 equals 36. So from here, I have 6 divided by 3, that is 2. I have 6 power 2 equals 36. And 6 power 2 is 6 times 6, which equals 36. And 6 times 6 here is 36. And this equals 36. So that is it. The answer, cube root of 6 or 6 power 1 over 3 has satisfied the equation. You can also solve this using a different approach, natural log. This is t power 3 equals 36. I can say let x equals t power 3, meaning I'm going to have t power x equals 36. Have you seen that? I can then apply natural log. Natural log of t power x equals natural log of 36. Have you seen that? Remember, if you have natural log of a power b, this equals b times natural log of a. So the x comes behind the natural log. I have x times natural log of t equals natural log of 36. Now, I can decide to express this in terms of x, going back to this equation. Remember, t power x equals 36 or x equals t power 3. From here, I can solve for t. That means if x equals t power 3, if I raise this to the power of 3 or 1 over 3, and also raise this to the power of 1 over 3, and multiply the exponent, I'm going to have x power 1 over 3 equals t. Have you seen that? So x power 1 over 3 equals t. This, I can simply have it as x power 1 over 3 equals t. So this t here is x power 1 over 3. I have x times natural log of x power 1 over 3 equals natural log of 36. Have you seen that? And remember the identity again. Natural log of x power y equals y times natural log of x. So 1 over 3 here can come behind this x. I'll have x times 1 over 3 times natural log of x equals natural log of 36. Have you seen that? So from here, x times 1 is x over 3 times natural log of x equals natural log of 36. So what do? I need to eliminate this. So I can multiply this by 3 and also multiply this by 3. Have you seen that? If I multiply this by 3, I'm going to have 3x over 3. That will cancel out. This is 3x over 3 times natural log of x equals, this will be 3 times natural log of 36. Have you seen that? So 3 cancel 3, will have x times natural log of x equals 3 times natural log of 36. Now, that is not all. I can have external natural log of x equals 3 times natural log of 36 is 6 power 2. So this comes behind again. And I have external natural log of x equals 2 times 3, 6 times natural log of 6. Of the same. If now I have x, I have 6, I have ln of 6, I have ln of 6. That means x equals 6. Let's go back to what is our x. Remember, we had an equation that t equals x power 1 over 3. Remember, t equals x power 1 over 3. T equals x power 1 over 3. So t equals 6 power 1 over 3. That means t equals a cube root of 6, which is exactly what we had earlier on. We've seen that. So this method is also an interesting method of solving. And that is it, guys. Thank you and goodbye.